So without much ado as well, ladies and gentlemen, permit me to hand over to the colleagues of Integration, Rainer Lemore and Red Fox, who are the consultants that have been supporting us in setting up the CDMS in the past years, to give a final workshop on presentation on the benefit of the central data management system as a tool for improving energy access. So at this point, I would like to hand over to, I think it is Frankie that will be the first speaker. Thank you very much.
Okay, so now we are presenting the workshop on the benefit of CDMS as a tool for improving energy access, data gathering, remote mapping, and monitoring operations. So my name is Frankie Eckersley. I am an engineer with experience in GIS and data management and working at Integration. So here is a brief agenda of the workshop today. So we're going to be following the Energy Access Toolkit. So this means we start with site identification and over to site development. So within site identification and development, we have 3 points of discussion. That is data gathering and its uses, the type of data collected, and ways to gather data. So this means we want to ask what data are we collecting and how are we collecting that. Finally, we will discuss the monitoring and evaluation of these site assets. So first, we start with the use case. So we try to imagine if you want to invest in a renewable off-grid energy project in Nigeria, how would you feasibly find a site for that with limited access to data available, which would then bring us on to our project objectives. So we want to be able to provide the most accurate data and enable electrification processes within Nigeria. So first, we try to identify the on and off-grid settlements. Secondly, we take a step closer into this identification by estimating the number of buildings in these settlements. Finally, to review the commercial, public, and productive uses there. And whilst we have evaluated the number of the buildings there, we would also be able to find a bit about the density of the buildings in the settlement. So here we have an example. So on the left-hand side, you can see a settlement as per the satellite imagery. And then on the right-hand side, that settlement has been digitized, which means that we have digitized the buildings, the roads, and also some land use areas within that settlement. For example, you can see in the south west of the location, there is a small industrial area marked in gray. So with this additional information connected remotely, we are able to better understand and estimate the energy demand of these specific areas. So there we can see the number of buildings, which is almost 3,000. The area, and then also the number of commercial users can be found. So now we look at the type of data we are collecting and processing. So we have basically 3 components that we have been collecting. That is the grid data, the infrastructure, so buildings, roads, and land use, and finally the settlements. Now we will look into these 3 different data that we have collected in more detail. So starting with the medium voltage grid, we can see that in green we have the areas where grid data is currently available. So grid data is currently available for 22 states within Nigeria, which translates to over 50,000 kilometers of medium voltage cables. In the CDMS at the moment, we have the data has been processed for 19 states, which means we are still working on 3 states, so they are within the data processing stage. That means that you can check the social media platforms and the website, and you will see that we will provide updates when we have updated the data for these 3 states. We also have differentiated between data which has been from secondary sources, that's in the south of the country with the light green, and also primary grid data, which has been collected from a primary source as part of this project. Additionally, remote mapping has been conducted in more states than we have grid data for, so you can see 25 states. This means over 3,400 off-grid settlements have been remotely mapped, which also translates to over 2.6 million buildings. Additionally to the remote mapping, we have all of the data available for all 36 states in Nigeria. That means that each settlement has been remotely identified through satellite imagery, and we can see two examples of how these settlements have been identified in the top left, and that is with a blue polygon outline. So that means we have the outline for these settlements, and therefore we would know the area. Okay, I would now pass over to our colleague Katerina Kada, who would discuss this data gathering approaches by remote sensing. Thank you for listening.
All right. Yes, so thanks, Frankie. My name is Katerina Kada. I'm a researcher at the Rainer Le Mon Institute here in Berlin. And yes, I will now present you how we use the techniques of remote sensing for data gathering, specifically for understanding where the settlements for which we would like to conduct energy access planning. So please, the next slide. So the very first question we ask ourselves is, how do we actually identify where we have the settlements which we want to look at? This is kind of the very base for all our planning, and therefore we need to find a way how to convert that actually kind of real-world information into digital location-specific geodata sets, meaning that we do have our GIS systems which we would like to use to run analysis, but we need to have that database. And in the last years, very fortunately, there have been major improvements in terms of data availability based on satellite imagery, which we could really make use of. So I've been part of the project of the NESP1 project from 2014 onwards. And I can really see that now with the launch of this tool, with the work for the Federal Ministry of Power, it's a very major stepstone in terms of data availability for planning. And it's not only for energy access planning. That data which we actually derived can also be, of course, used in other sectors where we would need that information on settlements of population. And as we have this data all available in the web map, not only the energy sector, but all others can also benefit from it. So the next slide, please. Then we continue and we look at the slides. So for actually then locating these settlements, we used kind of two base data, so remote sensing data, but also other geospatial data sets. That's on the first bullet point, I think. Yes. So there's the one data set called the high resolution settlement data set, which is based on a satellite circling across the globe and collecting reflectance information, which we can then actually use to derive different land use classifications, also such as settlements, for example, distinctively to other areas such as agricultural land or forests or water bodies, etc. And next. So that's kind of artificial intelligence which we use, or which was used to derive that high resolution settlement layer from that remote sensed satellite imagery. And we then also created customized GIS scripts in order to continue working with these data sets in a way that it was very useful for me. I will show this on the next slide. In more detail, on the right, you see the data sources we used. So that's actually a data set created by Columbia University in cooperation with Facebook. They made this data set available where for each pixel on the ground, a pixel is like the smallest ground unit we can distribute the data set into. We have that information if there's a presence of buildings. And with that, it can be then assumed that if there's a high value in that, there's going to be a settlement. This is represented in the picture with the different colors. So, for example, for the different colors, a lower or higher settlement density is assumed. And we grouped those pixels in order to then derive what we call the settlement clusters, which I will show you to you on the next slide. So here you actually see a settlement from satellite imagery. And now the question is, I mean, every one of us could go to Google Maps and look at that and see that, but we need to actually find a methodology in order to actually draw a boundary across this cluster to actually extract the information we want from that cluster, and also in order to combine it with other information. So maybe next. With our scripts which we developed, we could actually create these delineations, these boundaries across these populated areas, and then based on that extract information. Next, please. Next. So the information could be, for example, the area of that cluster, of course also its location, so which geocoordinates do we have at that site, but also in which Nigerian federal state it is located, and also in the LGA. But also, of course, we can calculate other things such as the settlement density, like how many houses in compared to the overall area do we have, and also conduct distance calculations. And then also we use this data to combine it with the other data sets we got from other parts of the project, for example, the grid tracking, to really understand where are the areas where we want to focus on and where we want to gather more detailed information, and how to actually improve on the boundary delineations, because right now you can see that it's a very rough polygon and it could be more detailed. So on the next slide, you can actually see how we then used a manual improvement step for the clusters. So you see the white polygons on the left side are the ones which stem from the automatic detection, and then we did the manual improvement where you see the blue lines, how then the land use residential was mapped in OpenStreetMap in order to refine the boundaries of the polygon. But in order to do so, we first needed the white polygons in order to understand where do we actually want to conduct these improvements on. And yeah, with that, I'm about to conclude that we did this for all of Nigeria. On the next slide, you can actually see that we have this advantage of using the remotely sensed data set as base data, so also in areas which are very hard to access. There was no coverage issues, and we could cover all of the country in order to derive these clusters, which are also now available in the web map and will form the basis for the further steps. With that, I would like to thank you for your attention and hand over to Professor Francis Okeke for continuing with our working steps. Thank you very much.
Great, thank you. Yeah, so here we are discussing the work that Professor Okeke was doing in terms of grid data gathering. So that means that we have been collecting secondary grid data, as we previously discussed, for 7 states, and that was provided by DISCOS within Nigeria. And then furthermore, we have collected primary grid data for 12 states in Nigeria. And this is done by driving along the 11 kV and 33 kV medium voltage cables. And these are immediately digitized via an app, an iPad, a geospatial mapping app, as the team are driving along these cables. So there we can just see a small video of the team driving along and conducting those mapping activities. So as I discussed before, this is about the software, that is used. So the team are basically driving along the medium voltage cables and using GIS software to map the cables. This data is then processed and uploaded into the CDMS. So that means we do some small data cleaning on these data sets to make sure it's all in order, and then we upload it into the CDMS. So this would also correlate to the remote mapped clusters and the clusters as described, the settlement clusters as previously described by Katerina. So that means that we compare the grid data to the cluster data and then calculate the distance between those, which is then updated in the CDMS when we push a new grid data set to be updated. So therefore the off-grid settlements are selected basically by combining these two data sets. So we calculate the distance to the medium voltage cable of these settlements, and then we select those that are over 5 kilometers away for remote mapping. So these are the settlement polygon outlines, as we previously discussed, those that are over 5 kilometers and also above a certain size. So this size here is 0.1 kilometers squared that we set. And then we choose the largest settlements in the state for mapping, based on the knowledge that these larger settlements will be more interesting for energy investments. So here we have some small video of the team which are conducting these remote mapping activities. So once we have filtered the settlements that we want to remotely map, the team will then start mapping these buildings there. So this is how the remote mapping is conducted. So the team will draw squares around the building, tracing the satellite imagery. These polygon buildings are then pushed to the OpenStreetMap platform and are also used within the CDMS. So far, over 3,400 off-grid settlements have been mapped in this way. So this is how the data for the remotely mapped clusters is currently available. The square polygon building outlines, they will be available to download via the OpenStreetMap platform, but we process these building data into more detailed remotely mapped clusters. So this is the blue outline as shown in the slide here. So the buildings are processed to calculate new clusters, which will then have a building count within them and also a building density number next to them. So these clusters are available under remotely mapped clusters on the Nigeria SE4All web map, and are also available to download via the data manager at data.nigeriaSE4All.gov.ng. Okay, and I will now go on to the conclusions for the data gathering discussion that we have just presented. So the data that we have collected so far is good for developing grid designs and understanding the potential of investments for these off-grid areas. The data can also be used for a demand assessment to understand how many buildings are within the settlements and to understand the size. And this is therefore used for estimating the costs and the financial modeling, because you need a demand assessment in order to understand the system size and therefore the financial modeling and costs required. And here we have a picture of the data used in this way. So we can see that the building polygons have been downloaded, and over the top a grid map has been drawn. This grid map allows us to calculate the amount of low voltage cable required to construct an off-grid energy asset at this site. And here we can see the amount of cable needed for this particular location is about 58 kilometers. and there will be around 1,400 low voltage poles needed to draw this grid at this location. And now just to summarize our achievements after 1 year. So we've gathered a huge amount of data for off-grid energy investments. So that's over 50,000 kilometers of electricity grid tracked, over 300,000 settlements, polygon outlines created, and of these 360,000, 3,400 of those have been remotely mapped. This then translates to over 2.6 million buildings remotely mapped. And we would like to give a final mention here to the mapathons that have been conducted. During the mapathons, we have students working with us, and we train them on the tools used for remote mapping. So far, we have conducted over 4 remote mapathons, and we have our 5th one upcoming on the 18th of November, and that is to celebrate World GIS Day, that is happening also on that date. So as part of the remote mapathons, we've had over 60 volunteers, and also mapped 30,000 buildings. And these buildings are also the off-grid locations, which are used within the central data management system. Okay, I would now hand over to Imran, who will talk about digital monitoring of these mini-grids once they have been installed.
Hi, Frankie. Thanks a lot. Hello, everyone. And once again, welcome for joining. My name is Imran. I'm working at Integration under our mini-grid development team. And I would like to talk to you today about the mini-grid monitoring platform that we have developed under this program and how it connects together with what has just been presented. Now, before I go into the details of the mini-grid tool and how it can be used, I would like us to take a step back and maybe talk about the importance of such a monitoring tool for the mini-grid sector in Nigeria. Next, please. Thanks. So as we already saw that there is a huge effort in the industry to help facilitate the growth of this sector. And I'm happy to share with you that we have really seen exponential growth in mini-grid market in the last few years. As you can already see on the map that, there are already 50 plus mini-grids that are operational out there in one form or the other. We have been able to actually tag a lot of them, and even more than 100 are actually currently under planning or development phases. What we also saw earlier in the day, especially in the panel discussion, that there are a lot of stakeholders involved, and each one of them definitely have different reporting needs. For example, NERC, NEMSA, then we also have donor agencies, and there is a need to simplify the process of this reporting. Furthermore, the sector is also going a lot of changes whereby a lot of new innovations are coming along. Nigeria has led the sector in mini-grids, off-grid mini-grids, and it is now again a leader in the market, especially for Africa in terms of innovating new interconnected mini-grids. And that also complicates the market already. And all what this means is that, there is now a need for cost reduction strategies to help growth of the sector beyond just a few prototype projects. And therefore, there is definitely a need for benchmarking. And what I can happily share is that our tool can do just that and to support that. Having this as a background, what we have done over the last 2 years is to kind of work on a methodology and come up with a concept for monitoring of such mini-grid systems, either off-grid or on-grid. Next, please. And as part of our concept, the approach that we have taken is that we have started with international benchmarks and already existing work that is out there in the industry. But on top of that, we have built a second layer and kind of learned from our experience. And what I mean by that is that under the NESP program, there have already been mini-grids that were commissioned in 2016 and 2017 that have now been operational for 2 years. And together with NESP and the support of FMP, we have been actively monitoring those projects and being able to understand how a typical monitoring approach can work, what are the limitations, and what are some of the realistic expectations from the sector. Based on that, we have come up with a framework and come up with some KPIs. For example, under social KPIs, we want to look at how many people are being reached, what are the effects of such a mini grid in terms of employment, economic uplift in the community. In terms of technical KPIs, we are of course looking at the generation side of things, what has the production been of the PV panels, how is the system doing overall. In terms of distribution network, what is it that we want to know, and what is it that we can actually know? Can we find out where are the main losses in the grid? In terms of financial KPIs, like I said, towards the line of going for benchmarking, we want to collect information about CapEx, about OpEx of projects, and then also some basic information about tariffs. In addition to these three main areas of KPIs, we have also incorporated in our approach to look at further reporting requirements that are useful for the sector and at some points also particular to the case of Nigeria. This includes, for example, identifying whether certain mini-grids have already been able to implement environmental and social impact assessments, to be able to very easily identify whether they are meeting with NEMSA's standards and regulations and codes as well. And once we have come up with this concept, our approach was next to come up with some digital tools to collect all this information. Next, please. And the first one among them was to collect information about social performance of these monitoring of these mini-grids. And the way we do it is by using open source tools like Copo Toolbox or other digital survey tools to collect information whereby an engineer or an expert is going on site, collecting information on site in offline mode, because often these communities are in areas where data connectivity is a big issue. But then we are able to collect this information and then synchronize them as soon as they are back into the network. And using this digital tools allows us to build an API whereby we are directly importing this information for our monitoring platform, which I will show you further. Next, please. In terms of the technical monitoring of mini-grids, a key focus of our approach has been to standardize reporting processes. Because what we have learned from our experience is that every site is unique and there are different challenges when the expert is on site to collect data. For example, you can see that our expert has gone to one of the sites and he just find out that the cable there is just of a different type, what he took along. Now he cannot go back and collect all this information. Therefore, we have tried to come up with standard processes to already inform our team and the developers, this is the basic information you need to provide, and kind of help them to facilitate the process and get all data accumulated. And of course, another important point that we have done is to make sure that our approach, while allowing for automation and collection of data via APIs, there is always a secondary channel to provide data manually. And we feel this is an important step which is needed at this stage in the sector, where not every mini-grid out there has a smart meter or has data connectivity to be able to provide data automatically. Next, please. And the third leg of our data collection is basically the financial information about these mini-grids. And there, our key source of information are the companies. And what we work here is that we have provided a platform whereby the developers are able to join our system, use a secure account, and be able to upload their financial information in a secure platform where we have ensured data protection and privacy, so that their information is only being that they are the only one who can see the information or update their information, and it provides them a level of comfort as well with the system. And that has been a key that we understand as a key driver to build this relationship with these developers, to get them on board into such an exercise. Having collected all this data, now our next step was to bring all of this together into a central system which is backed by the CDMS. Next, please. And this you see in the culmination of a mini-grid monitor, which was also presented earlier in the technical launch as well. And here you can see that when we collect all this information using different methods, we are able to bring it all together into a central platform. So far, we have already been able to collect information for 35 sites in Nigeria. And that is just not all. We are at the moment also actively pursuing information for 50 other sites out there that are either commissioned or very near to commissioning. And what you can see that basically the tool allows us to look at entire portfolios. That's a collection of sites. But then for individual developers, it allows them to also go to individual sites and then be able to monitor them much more closely as well, using the technical indicators, the social indicators, and the financial indicators that I just talked about. Now, before I move on, I would like to now talk a bit about how we can use this platform and what are some of the advantages of this platform. We just talked about the first part of the presentation, the need for identifying viable locations for mini-grids. Why do we want to do that? To further support the process of energy access in Nigeria. Now I want to give you some examples how our tool can help in that direction as well. Next slide, please. So our first stakeholder in this process are, of course, the developers and the investors who are backed by them. And I want to give you a couple of examples of what kind of information this platform can provide them and how it can be useful for them. So as we learned earlier in the discussion panel as well, that there is a very complex reporting process, which is supposed to be now much more simplified. And a lot of actors are coming together to do that. And this platform is another stone in the same process, that we provide a platform whereby a developer is able to automatically generate reports on key statistics of their project and make them available to regulators as part of their monitoring, as part of their reporting. And these processes can in future also be automated, whereby the regulator is directly receiving this information periodically. And this will relieve a lot of burden from these developers. The second question that they might want to ask is, how are my projects doing compared to others out there? And just as an example, consider a developer who has developed a project under a program like an NESP, and there are 10 different projects which were also developed. Now, when this developer is joining this platform and providing his information, he is able to also see aggregated information of the entire portfolio as well. And this allows him to also compare his results against the average aggregated results of the entire program and be able to see where he is doing right and where he is going wrong. For example, now in your screen, you see that we have information about revenue of the projects over year and year. And you see that a developer can easily compare with his own numbers, which he of course has with himself, and be able to say, are my projects below the average or doing better than others? And this can definitely also help him to scale up in future and improve his projects further as well. Next, please. The second important stakeholder that we have in the process are the donors, and how such a tool can help them support the sector. First of all, improve and then grow as well. The first key question that we want to ask here is that, can we drive benchmarking data from the sector? This is what we also emphasized earlier on, that now that the industry is beyond initial stage and is maturing actually, there is a need for benchmarking. And just having all this information, so at the moment we have 35 mini-grids. Just imagine that 2 years down the line, when we have 200 mini-grids, then the level of certainty that we can have about the data that we are collecting and the benchmarking that can be done, that can really provide incentives to drive the sector further as well. The second thing that we feel can be used, can be a good benefit out of such a platform, is to identify target areas where further assistance could be needed. For example, as we have learned under the experience of NESP, in monitoring the mini-grids that are out there, that the projects that have been installed, they had an initial uptake of demand, but after a certain point, they reached saturation. That means there was no further growth in terms of energy consumption. What we have been able to monitor and find out is that the residential connections, normal households are being connected and they are using what they usually do. But what we are seeing is that the productive use segment has not taken up as it was hoped for. And of course, that is a key part of mini-grids, to make them sustainable in the long run. And such a learning has helped to drive a key work stream at NESP, where our focus is much more on demand stimulation and targeted support to businesses out there, identifying an electric motor identifying a business and helping them to grow for themselves, and then also making the mini-grid sustainable as well. Now, finally, the last stakeholder that I would like to talk about are the energy institutes. Next, please. And this is really the culmination of what we talk about today. How can policymakers be supported in promoting energy access and making policies that drive the sector further? One question that, again, we start with the approach, how things have been going and how we can make them better. The first question is really about, are the projects that are out there meeting their targets? So different programs have been launched with different incentive mechanisms, different business models in terms of different connection fees. Some have a higher connection fee but a lower tariff. Some work with higher tariffs but a lower connection fee so that more people are connected. And via such a platform, you can really see which mechanisms are working and which are not working. So you can compare across different programs and easily create portfolio insights. And then, of course, all this leads to the fact that we want to find out whether all this effort and policies are helping us improve energy access, whether all this is bearing fruit or not. And this is really what this platform is about, to show how the access to energy and how the access to electricity is being improved over time and what can be done further. So such an overview across a program, across the entire country, and maybe eventually also across the regions also can help to drive such policy decisions that these kinds of programs work. So let's replicate them. These kinds of programs need support and let's provide them support. And I think this is really the message today that, you know, that these monitoring of these mini grids is not just about making existing systems better, but rather using them as a tool for driving benchmarking results and insights to drive the sector further. Next, please. And again, there you have it. This is the toolkit that we talked about under the CDMS that we have been able to launch today. I'm very happy to do that. As you see that together with Frankie, we together went through the journey of how these tools can be used for site identification, actually narrowing down to the more viable sites, remotely mapping them, mapping the grid, supporting the development of sites via these digital tools. And then finally, and also importantly, being able to monitor them, not only to make these projects better, but also to further stimulate more investment and more growth in the sector, and eventually help support the objective of energy access in the country and beyond. Thank you very much for your time. And I will hand over back to you.
Thank you very much for that great presentation. I think my special thanks go to Frankie from Integration and equally Catherine from Rainer Lemore Institute, then Francis Okeke of Red Fox Nigeria Limited, and you finally, Imra from Integration, who gave us the last insight. I think what you guys showed us now is basically how much work that has been done to provide the most accurate data that will enable Nigeria electrification progress in the future. So for the data gathering, the insights we got from data gathering to remote sensing to the primary data collection on ground by Red Fox from pole to pole to reach 50,000 kilometers of the grid data collected. I think it gives us the realization that there is a lot of work behind all that has been displayed here today. So thank you very much for shedding more light on the mini grid monitoring tool as well.